Yeah. Next topic is critical section problem. Here, the critical section is it can be, we can say it is a code or a part of a program. Okay. We say this critical section is nothing but a set of some instructions, we call it as a critical section, or some part of a program, we call it as a critical section. Okay. Which contains the access to the shared variables and has to be executed as an atomic action. Okay. Critical section is nothing but it's a code or part of a program which contains access to the shared variables. Okay. That shared variables will be shared among the multiple processes at a time. Okay. Here the critical section is a code or part of a program which contains access to shared variables and has to be executed as a atomic action. Okay, so we'll discuss with an example this critical section problem. Like consider the airline ticket reservation system. Okay, like assume that if there is only one seat is available for reservation. Okay, and if three persons are booking a ticket at the same time, what will happen? Only among these three people, any one person can allot, get the seat allotment. Okay, so here we have in this airline ticket reservation system, if only one seat is available, if three persons are booking the ticket at a time, only one should be allowed to block the seat. Okay, else it will lead to data inconsistency. Okay, if in three members, if the seat is allotted for the two members or seat is allotted for the all three members, there will be a problem will rise, like who can avail the seat that time. Okay, so the code which allows for updation of the seat variable is the critical section. Okay, here the code which allows the access of that seat, that is called a critical section. Understood, right? Like in airline ticket reservation system, if there is a single seat is available, three persons are tries to book the ticket. Okay, but only one should be allowed to block that seat. Okay, else what will happen? That will lead to data inconsistency problem. Okay, so the code which allows for updation of the seat variable is called the critical section. Understood, right? Next, we'll in detail we'll understand this critical section problem. We'll consider a system consisting of n number of processes, like process 0, process 1, process 2, process 3, until process n minus 1. We have a system is having n processes. Okay, each process has a segment of code. Every process will be having a part. A segment of code is nothing but some set of instructions are part of that process code. Okay, each process has a segment of code that is called as critical section. Okay, in which the process may be changing the common variables. Okay, what in critical section, what will be there? The process, it have the way of accessing the shared data. Okay, in this critical section, the process may be changing the common variables or updating a table or writing to a file. Okay, like that. Okay, that things will be call it as a critical section, where the common variables are getting updated, shared data has been modified. That part we call it as critical section. Okay, and each process has a segment of code that is called critical section, in which the process may be changing some common variables or updating tables or writing files. Okay, that we call it as a critical section. Okay, the important feature of this system is that when one process is executing in its critical section, no other process is to be allowed to execute in its critical section. Understood, right? Concentrate here. When one process is executing in its critical section, no other process is to be allowed to execute in its critical section. Okay, what the critical section consists of? Section consists of shared data. Okay, if one process is accessing that critical section means no other process should not be allowed to execute in its critical section. Okay, so that if any one process modifies, later other process can access the data. Okay, so that's the reason here important feature of a system is that when one process is executing in its critical section, no other process is to be allowed to execute in its critical section. Okay, that is, no two processes are executing in their critical section at the same time. Okay, for that we have a structure for this process. Okay, so the critical section problem is to be designed a protocol that the processes can use to cooperate. Okay, here the critical section problem will design some set of rules so that the processes in the system can cooperate each other. Okay, so we can avoid the data inconsistency also by using this critical section problem. Okay, each process must request a permission to enter into a critical section. Okay, you can see here each process, this is the process. In this we have, this part is called as critical section. Okay, and each process must request a permission to enter into the critical section. Okay, the section of code implementing this request is called as entry section. Okay, in this entry section each process will request permission to enter into this critical section. Okay, and here the entry will be given for only one process at a time. Okay, critical section entry will be given to only one process at a time in the system. Okay, and when one process is executing in critical section, other process should not try to enter into the critical section. Okay, only critical section will be given for execution only one process at a time. Okay, understood, right? Each process must request a permission to enter into the critical section. The section of code implementing this request is called as entry section. Okay, next, the critical section may be followed the exit section. Okay, after completing the execution of critical section, process may exit that critical section. Okay, that is called exit section. Okay, critical section will be following a exit section. Okay, and the remaining code is called as reminder section. Okay, like this is the structure of a process. A process, every process will have some set of instructions, we call it as a critical section, where shared variable will be there or shared data will be there. So only one process can access the critical section at a time. Okay, when one process is inside the critical section, other process should not be in critical section. Okay, when one process will exit the critical section, then only other process can try to enter the critical section. Okay, this is the critical section problem. Okay, now we'll see the solution to critical section problem. Here the solution to critical section problem is, the first one is mutual exclusion. Okay, mutual exclusion means if process pi is executing in its critical section, then no other processes can be executing in their critical sections. Okay, that's what we discussed, right? If one process is executing in its critical section, no other processes can execute in their critical sections. Okay, at a time only one process can execute in critical section. That is called mutual exclusion. Okay. Next, another solution for the critical section is progress. Okay. If no process is executing in its critical section, okay, if there is no process is executing in its critical section, and some processes wish to enter into their critical sections, okay, then only those processes that are not executing in their remainder sections can participate in the decision on which will enter into its critical section next. Okay, and this selection cannot be postponed indefinitely. Okay, this selection should happen immediately. Okay, understood, right? Progress. If no process is executing in its critical section, that means critical section is no process is accessing the critical section. Okay, uh, no process is executing the critical section, no process is inside their critical section. Okay, at that time some processes are wish to enter into their critical section, then only those processes that are not executing in the remainder sections can participate in the decision, like which process can enter to the critical section next. Okay, and this selection cannot be postponed for the longer time. Okay, this selection cannot be postponed indefinitely. This is progress. Okay, when one say only mutual, what the mutual exclusion says, if process one process pi is executing in its critical section, then no other process can be executing in their critical sections. Okay, next, progress is if no process is executing in its critical section and some processes wish to enter their critical section, then only those processes that are not executing in their remainder sections can participate in the decision, like they can participate in the competition which can enter to the critical section next. Okay, and this selection cannot be postponed indefinitely. Okay, this is another solution to critical section problem. Next one is bounded waiting time. Okay, there exists a bound or a limit. Okay, there will be a limit on the number of times that other processes are allowed to enter into their critical sections after a process has made a request to enter its critical section. Okay, there will be a limit will be there, there will be a bound will be there on the number of times that other processes are allowed to enter into their critical section after a process has made a request to enter into its critical section. Okay, and before that request is granted. Okay, there will be a limit for every process, the number of times that processes are allowed to enter into their critical sections after the process has made a request to enter into their critical section. Okay, this will be checked before that request is granted to that process to enter into the critical section. This is called bounded waiting. These are the solutions to critical section problem. Okay, what the critical section problem says, if one process is executing in the say critical section, no other process can be executing in their critical sections. Okay, and if the critical section is free, that means no process is executing in its critical section, and if some processes are wish to enter into their critical section, then only those processes that are not executing in their remainder sections can participate in the decision which will enter its critical section next. Okay, and that selection also cannot be postponed for indefinite time. Okay, And next is bounded waiting. There will be some bound or limit on the number of times that other processors are allowed to enter into their critical sections after a process has made a request to enter it into its critical section. Okay, and before that request is granted. This is the solution to critical section problem. Next, we'll see the general approaches used to critical section in operating system. Okay, here we have two general approaches are used to critical section in operating system. That is preemptive kernel. Okay, preemptive kernel and non-preemptive kernel. What is preemptive and non-preemptive, which we have discussed when we are discussing the process scheduling? Okay, preemptive means once the process is allocated to the CPU, the process will be preempted if any higher priority process comes for the execution by the processor. Okay, that is preemptive. Non-preemptive is nothing but once the process is allocated to a CPU, the process will not leave the CPU until completion of its execution. That is non-preemptive, right? Here, the preemptive kernel allows a process to be preempted while it is running in the kernel mode. Preemptive itself is nothing but that process will be allowed to preempted when it is running, right? That is called preemptive. Here, the preemptive kernel will allows a process to be preempted while it is running in the kernel mode. Okay, and it is difficult to design for the SMP architectures. Okay, since in these environments it is possible for two kernel mode process to run simultaneously on the different processes. In SMP architecture, what will do? There will be there is a possibility for kernel mode processes to run simultaneously on the different processors. Okay, there will be more than one processor will be there, and more than one process can run simultaneously on the different processors, right? In SMP architecture, and it is more suitable for the real time programming as it will allow a real time process to preempt a process currently running in the kernel. Okay, it is suitable for real time programming as it will allow a real time process to preempt a process which is currently running in the kernel. Okay, and preemptive kernel may be more responsive. Okay, and since there is less risk that kernel mode process will run for a arbitrarily long period before giving up the processor to waiting processes. Okay, this preemptive kernel may be more responsive because there is a less risk that kernel mode process will run for an arbitrarily long period before giving up the processor to waiting processes. Okay, this is preemptive kernel. Okay, now we'll see non-preemptive kernel. What the non-preemptive kernel will do? It does not allow a process running in the kernel mode to be preempted. Non-preemptive is nothing but once the process is allocated to the processor, process will not leave the processor until it completes its execution. That is non-preemptive. That's what we have studied in the previous session, right? Non-preemptive kernel does not allow a process running in the kernel mode to be preempted. Okay, a kernel mode process will run until it exits kernel mode. Okay, blocks or voluntarily yields the control of the CPU. Okay, understood here? Concentrate here. The kernel mode process will run until it exits the kernel mode. Okay, or it blocks or voluntarily yields the control of the CPU. Okay, it is essentially free from the race conditions on kernel data structures, as only one process is active in the kernel at a time. Okay, here you need to remember what is preemptive kernel, what is non-preemptive kernel. What the preemptive kernel will do, it allows a process to be preempted while it is running in the kernel mode. What the non-preemptive kernel will do, the non-preemptive kernel does not allow a process running in the kernel mode to be preempted.